So today we're starting set theory, so 7.1 in your notes. So first note to take, please, a set is a collection of terms often written inside curly brackets, for example like this. And the set of items in a situation is called the universal set, which is this squiggly sort of capital E. So just pause the video and that's your first note, please. So carrying on, starting off with example 1. So let's say that our universal set was the numbers 1 to 10. And I was asking you to write out set A, which is the even numbers. So you basically just select all the even numbers from a universal set, which would be 2, 4, 6, 8, and 10. And if I was saying the question was set B is all the numbers less than 4, again, go back to your universal set and hook out all the numbers from there that are less than 4. So that would be 1, 2, and 3. Now, the next note I want you to take, please, is what's called a complement of a set. Now, a complement of a set is a list of all the numbers that are not in the set. So the complement of A, and by the way, we write this as being A dash. The complement of A are all the numbers in the universal set which are not in A. So what's in this universal set which is not 2, 4, 6, 8, and 10? Well, that's 1, 3, 5, 7, 9. Similarly, the complement of B is everything in our universal set, the numbers 1 to 10, that isn't in B, so isn't 1, 2, 3. So that's going to be 4, 5, 6, 7, 8, 9, and 10. Right, our next example we did, so this is a brand new example, so copy it down, please. Let's make our universal set the numbers 1 to 6. Let's let A be all the even numbers and B be numbers greater than 3. So what are our members of A? Well, they're the even numbers in our universal set, so that's 2, 4, and 6. B is the numbers in our universal set greater than 3, well, that's 4, 5, and 6. The complement of A are those numbers in the universal set that are not in A, they're not even, so that's 1, 3, and 5. And our complement of B, so it's the numbers that are not in B that are in our universal set. So not in B, so that's the 1, 2, and 3. Now, a final couple of definitions, guys, so please make a note of this too, is what's called the intersection, and it's this symbol here. So it's like an upside down hoop. So A intersection B, this means anything that is in both set A and in set B. So looking at what's in set A and set B, A intersection B will be the 4 and the 6, because those are in both A and B. So that's what intersection means. The other term we need to learn is union, which is like a U. It's like an upside down hoop. Now, A union B is all the members that are in either A or in B or in both. So what's in A or B or both? Well, that's the 2, 4, and 6 from A, and also the 5 from B, so 2, 4, 5, 6. You don't go and double count the numbers that are in both. So then the final note we took is when we introduced Venn diagrams. A intersection B is the area which is in both A and B. That would be this bit in the middle. A union B would be the area which is in either A or B or both. So this area here. And an example of the complement of B, everything that is not in B. Well, this rugby ball here is everything that is in B. So not B would be the rest of the Venn diagram. So make notes on this, please. Then have a go at the worksheet that I've attached on the email, please. And then upload your answers onto Dr. Frost.